This is my Forces Reassessment, and the problem I chose was find the tension in strings 1 and 2 supporting a 20 Newton rock hanging from the ceiling. Strings 1 and 2 make angles of 30 degrees and 40 degrees with the ceiling respectively. So our theta 1 angle is 30 degrees, theta 2 is 40 degrees. This is string 1 and that's string 2. This is the rock and that's gravity pulling down on it. So it gives us the weight of the rock in 20 newtons, and weight is equal to mass times gravity, W is equal to mg, and the units for mg are newtons, so it's already in mg, so we don't have to worry. The weight is already given in newtons, we don't have to worry about that. So to start out, we establish that the summation of the forces is equal to 0 because it's in equilibrium. And so the summation of the forces in the x direction are 0, the summation of the forces in the y direction are 0. So the summation of the forces in the x direction are negative tension 1, because it's going in the negative x direction, plus positive tension 2, because it's going in the positive x direction. And then for the y, it's tension 1 plus tension 2 plus the negative weight of the rock, or minus the weight of the rock. So then for the f of x, we need the x component of each angle, and the x component of each angle is cosine. So we just take this here and we put the cosine here and here. Cosine of angle 1 with string 1 and cosine of angle 2 with string 2. That's equal to 0. And over here we go for the y component of the tension, which is sine. So we have sine of the angle 1 with string 1, and then string 2 with the sine of the second angle, minus the weight of the rock is equal to 0. So to solve for this, we move t2 cosine theta 2 to the other side, divide by cosine of theta 1, and we're given T1, or the tension of string 1, is equal to tension of string 2 times cosine theta 2 times, or divided by cosine of theta 1. And now over here, we come over here and we insert our T1 here, substitute in. Then we see that T2 is common in both of these, so we put them together and take out T2, factor out T2, move the weight of the rock to the other side so it's positive. So then we're given T2 is equal to the weight of the rock divided by sine of theta 2 plus cosine of theta 2 divided by cosine of theta 1 times sine of theta 1. So then you come down here, we plug in what we know. Weight of our rock is 20 newtons, sine of theta 2 is 40, plus cosine of theta 2, 40 divided by cosine of theta 1, 30 times sine 30 is equal to 18.4, so 18.4 newtons is our T2. And so over here, we come back and we can find our T1. And so T2 times cosine theta 2 divided by cosine theta 1, 18.4 newtons times cosine of theta 2, which is 40, divided by cosine of 30. And that gives us T1 of 16.3 newtons. So the tension in string 1 is 16.3 newtons, tension in string 2 is 18.4 newtons.